Here's our first example problem for Chapter 23. We're going to be looking at resting pulse rates for smokers versus non-smokers. So here's our situation. Resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. In our second group, which was 32 randomly chosen non-smokers, the mean and standard deviation were 74 beats per minute and 6 beats per minute. Both sets of data were graphed. Their graphs showed a roughly symmetrical shape, had no outliers. So we've got that nearly normal condition set. Is there evidence of a difference in mean pulse rate between smokers and non-smokers? This is what we're trying to find. So the hypothesis, let's set this up. The hypothesis is that the two groups will be the same, right? The pulse rate for smokers and non-smokers does not differ significantly. So we have the mean of the smoker group minus the mean of the non-smoking group equals 0. So remember to use subscripts that are meaningful. And it makes sense to put the smoker group first and subtract the non-smoker group because we're probably anticipating that smokers would have higher pulse rates. The alternate hypothesis is that the pulse rates for smokers and non-smokers are different. We have smoker mean minus non-smoker mean does not equal 0. The question that we were asked on the prior slide at the bottom said, is there evidence of a difference in the rate? It didn't ask or imply a direction. Since no language suggested that direction, we're going to do a two-tailed test. So what's our model? The problem states that we have random samples, so that's checked off. The pulse rates for smokers are obviously independent from the pulse rates for non-smokers. These are different people. Each sample is less than 10% of the population from which it's drawn. Certainly, that would be true. And we were told that both graphs appear to be approximately normal. So the assumptions and conditions are satisfied. We're going to proceed to construct a two-sample t-test about the difference between mean pulse rates for smokers and non-smokers. Remember, you do need to name the test that you're using. So the mechanics, here are all the values that we have. In our smoker group, we had 26 participants. Y bar, which you could use X bar, this is the mean, is 80 beats per minute, and the standard deviation is 5 for the sample. Of my non-smoker group, I have 32 people involved. The heart rate was 74 with a standard deviation of 6. We need to calculate a t-score, and if you look at this this format, you can see it looks like all the other formats that we have for t-scores or z-scores. We have the difference from our sample minus the population difference, which is our hypothesized difference, divided by standard deviation. And in this case, our standard deviation, we will basically group these guys together to come up with our standard error. We have to work through variances, though. This is standard deviation squared, which represents the variance for the smoker group. This is standard deviation squared, which represents the variance for the non-smoker group. We'll add those two things together and take the square root, and we're good to go. So the t-score ends up being 4.15, cranking that thing out manually. Our p-value is less than 0.0001. And the degrees of freedom is 56. Now the degrees of freedom we have to get from our calculator. Well, there is that formula on page 607, but we're better off using our calculator for this. So I am actually going to show you two things here. I'm going to show you how to get this p-value off of the table, and I'm going to show you how to get all of this off of the calculator. Okay, so the first thing, if I wanted to find my p-value, I have a t-score of 4.15. I'm good with that. I need degrees of freedom even to use this table in my book. I don't know my degrees of freedom. What I do know is that in my two groups, one group was 26 people, the other group was 32 people. I know that my degrees of freedom will be somewhere around the sum of those two numbers, which is 58. So I could, I could use 58 off of this table. That would be close, not exact, but you know what? 58's not even on the table. So what do I use? Would I have to use 60? I don't know. If I did use 60, my t-score of 4.15 is all the way off the chart. 4.15 is not even on this chart. So that would basically tell me that my p-value is less than 0.0005, which is certainly enough information to be able to make a conclusion about this hypothesis test. So the point is that we need degrees of freedom to find p-values using a table. We need our calculator to find degrees of freedom. So basically for these, you're going to be relying on your calculator a lot. So let's go ahead and do let's crank out this problem with the calculator. So I'm going to go to Stat. Well, turn on your calculator first. Go to Stat, Tests, and it's number 4, 2 sample t-test. Okay, 2 sample t-test. And you have a choice to put in the data itself, and that would be like using list 1, list 2. In this particular one, we are just given summary statistics, so we don't have our individual data. There may be some problems you'll encounter where you need to input your data and then run it from there. In this case, we'll just move over here to Stats. As soon as I hit Enter, it's going to change my entry. And my first group, I'm going to put in my smoker information first. The mean pulse rate for smokers was 80 beats per minute. And the mean was 5 beats per minute. And the number of smokers I had, 26. My group 2 is my non-smoking group. I had, let's see, what they have, 74 beats per minute. Their standard deviation was 6. And I had 32 of those subjects. The rest of the things that they're going to ask is, whether it's one-sided or two-sided. We're going two-sided, so I'm going to choose that first one. Pooled is asking about the standard error work. We're always going to select no for pooled values here. Now, I know the standard error formula looks like we're kind of pooling values together, but it's not in the same way that we pooled them with the proportions. Pooling is a little bit different. There's some information in your text on that. Basically, we want to always choose no. I'm going to calculate this, and here are my results. I am given that my alternate hypothesis that the means are different. There's my t-score, 4.15 and some change. My p-value, it looks like 1.12. Remember, this is a percentage. You got to pay attention. This is in exponential notation. This is 1.12 or 1.13 times 10 to the negative 4th power. So you got to throw in 4 zeros, or you got to move the decimal place over 4 places to get that. Degrees of freedom is 55.95. In our slideshow, we wrote degrees of freedom as 56. Degrees of freedom needs to be a whole number, so you would just round there as appropriate. All right, I'm going to switch back to the PowerPoint. I think this is off a little bit. The p-value is approximately equal to 0.0001. If you were just using the table, we might say it's less than 0.0005. But I would probably change this to approximately equal to. Anyway, the other thing that we always need to do is to draw a curve, and we would put our degrees of freedom. This is a t distribution based on 56 degrees of freedom. Mark your hypothesized mean, which is the mean of, in this case, it's the difference between the two means. That would be the center of our distribution. If we subtract our two means, we get 6. So this is where we would want to mark where we are with our samples. And this should be shaded in here to the right. I'm not sure why it isn't shaded. Oh, this is hard to do with my trackpad. Anyway, that's the area we're looking for. There's my corresponding t-score for that location. And the p-value is approximately equal 0.0001. Alright, let's conclude this thing. Because the p-value of 0.0001 approximately is so small, the observed difference in these two means is unlikely to be just sampling error. We're going to reject the null hypothesis. We have strong evidence of a statistically significant difference in mean pulse rates between smokers and non-smokers. Guys, notice the language that's used here and the context of the problem. If the null hypothesis were true, and the mean pulse rates are the same, then a difference of 6 beats per minute that we see in our study would occur in less than one sample out of 10,000, or approximately one sample out of 10,000, simply by chance alone. That's pretty unusual. So we want to look at, how big of a difference, do we have here? What are we talking about? So if we look at a confidence interval, the confidence interval, the center of the interval is going to be the difference in our means, plus or minus the margin of error. The margin of error is made up of my t critical value for 56 degrees of freedom times the standard error, which is the sum of our the square root of the sum of our variances. If we plug in all the values, then we would get this. How do we get a t critical value for 56 degrees of freedom? Well, we can do that on our calculator. We need a confidence level too. We'll look at that on the calculator. I think it's 95%. So to remember to get a t critical value, we're just going to use inverse t distribution and look at the use the area in the tail, one of the tails, left or right, and then use that to get our t-score. So we're going to use inverse t. It's on second distribution, number 4, inverse t. The area, I'm just going to use the bottom area. So 95% in the center leaves 5% for both tails. Half of that on the left would be 0.025. My degrees of freedom is 56. And we'll calculate that. It's working. 2.00324 and some change. So that's how you get your t critical value for your confidence interval. Remember, your confidence interval uses the t-score related to whatever confidence level you have chosen. In this case, we're going to use a 95% confidence interval. It is not the t-value that goes with your sample data that you've been working with. Alright, back to the PowerPoint then. Yeah, there's our t-value that matches what we just got on our calculator. So if you crank out all these values, you get that the difference between the smoker and the non-smoker group will be between 3.1 beats per minute and 8.9 beats per minute. And because we did smokers minus non-smokers, this would be smoker pulse rates larger than non-smoker pulse rates. So let's conclude. Here's one good conclusion sentence. We're 95% confident that the mean pulse rate for smokers is between approximately 3.1 and 8.9 beats per minute higher than for non-smokers. A couple important things here. We state our confidence level. We state some context. We are talking about average or mean pulse rates. We have our confidence interval between 3.1 and 8.9. Units of measure, beats per minute. And then we show direction and comparison between smoker group, which is higher than non-smoker group. So we also get direction. Okay? The next sentence goes on to show, it's just further, that a 95% confidence interval gives us 95% success rate in capturing the true difference in heart rates here. In the end, we don't know if our interval actually captured the true heart rate difference or not, but based on this example, this is what we have. Different samples would give you different results. Okay? Next video is on pizzas.